Hello students, today in this session we will be discussing the chapter aldehydes and ketones. So first let us discuss the definition, then we will discuss the system of naming. We have two system of naming. One is the common system that is generally used for these aldehydes and ketones. Another one is the IUPAC system of naming. What are these aldehydes and ketones? Aldehydes and ketones are referred as carbonyl compounds. First I will tell you what do we mean by these carbonyl compounds. So compounds that contain carbonyl group, that is C double bond O group, are referred as carbonyl compounds. So in carbonyl compound we come across different classes of compounds like aldehydes, aldehydes, ketones, and carboxylic acids and their derivatives. So the compounds that contain C double bond O group are referred as carbonyl compounds. These carbonyl compounds includes aldehyde, ketones, carboxylic acids, and the other derivatives also. Let us first discuss what is this aldehyde and a ketone. If the groups attached to this carbonyl carbon, two groups will be attached to this carbonyl carbon. Out of these two groups, if one is hydrogen or if both are hydrogen, no problem with that. If at least one is hydrogen, then such compounds are called aldehydes. That means they contain C double bond O H group. Or this may be, so these are called as aldehydes. If both the groups attached are alkyl groups, then we call them as ketones. So aldehydes and ketones, these are carbonyl compounds because they contain a carbonyl group. The difference is in aldehydes, the C double bond O group is directly linked to hydrogen, whereas here in ketones, both the groups are attached to carbonyl carbon are either aryl or an alkyl groups, or one is alkyl or one may be an aryl also. Let us first go for the system of naming or the nomenclature. Now, the name of aldehydes in the common system or the trivial system, the name of aldehydes is derived from the acids. The terminal ic acid is replaced by a suffix aldehyde, for example. So you're very familiar with this. This is formic acid. So generally in trivial system, for acids, if there is one carbon, we use the term form. If there are two carbons, we use acid, ACET. If there are three carbon, we use propion. If there are four carbon, we use butyl. Such system. Now, this is an aldehyde. So this is an acid. For carbonyl group, there is an OH group attached. We call this an acid. This is an aldehyde, right? Now, so here the name is derived from this. The terminal ic acid is replaced by aldehyde. Formaldehyde, we call it as a formaldehyde. For example, this is acetic acid. This is referred as acetaldehyde. Acetic acid, the terminal ic acid is replaced by aldehyde. In the common system, that means generally for acids, if there is one carbon, we use form. If there are two carbon, we use acid. For three carbons, we use propion. For four carbons, we use butyl. Now, if there are substituted aldehydes, if there is a substitution, Then the position of the substituent is indicated by using a Greek letter: alpha, beta, gamma, delta, so on. So let us take an example. Here this compound CH3, CH2, CHCl, CHO. Now there are 4 carbon, hence butyl. If it was acid, we would have named it butyric acid. If it's an aldehyde, butyraldehyde. There is a substituent chloro, so chlorobutyraldehyde. In common system of naming, the carbonyl carbon, next carbon is alpha. This is alpha, this is beta, this is gamma. But here the substituent is linked to alpha carbon, so it is called as alpha chlorobutyraldehyde. It was linked here, then it would have called it as beta chlorobutyraldehyde. So such terminologies are used. Okay, so this is for the aliphatic aldehydes. This is what we follow. For aromatic aldehydes, the simplest aromatic aldehyde is this molecule. Okay, benzaldehyde. Okay, this is benzaldehyde. If it was acid, benzoic acid, it is benzaldehyde. Okay, now if there is a substitution on this benzaldehyde, that means aromatic aldehyde, if there is a substitution on benzaldehyde, then the position of the substituent is indicated by prefixes ortho, meta and para. So you are familiar with this. If it is present on the next carbon, we call it as ortho. If it is present here, we call it as meta. 1,2 position is referred as ortho, 1,3 as meta and 1,4 as para. So this is 1,2 position, so we call it as ortho or just as O. Okay, this is benzaldehyde. So orthohydroxybenzaldehyde. You can call it as orthohydroxybenzaldehyde. Right now, so some substituted aldehydes have special names. So this molecule is salicylaldehyde. This molecule is salicylaldehyde or salicylaldehyde is what we call it as. Okay, so this is the common system of naming. Let us go for the IUPAC system. Okay, in IUPAC system, so first the root word is decided based on the number of carbon atoms that are present. Then if there is an aldehyde functional group, then the suffix is used is al, and if there is substituent present, so they are written as a prefix, and the numbers they are indicated, the position is indicated by using the Arabic numerals 1, 2, 3, so on. For example, we'll take this example, simple. The same molecule which I had taken to explain right now. So what you should do? Count the number of carbon. Select a chain. You should select the longest carbon chain, continuous carbon chain, which should include the functional group carbon, aldehydic carbon. So this is the chain 1, 2, 3, 4. If there are 4, then the root word is but. Carbon carbon single bond, butane. Butane. Functional group is aldehyde, butanol. Al is used. Then there is a substituent. Substituent is chlorobutanol. Okay, the position of the substituent is indicated by indicating the position is indicated by using the numbers 1, 2, 3, so on. So you should number the chain that you have selected. So the numbering should be such that the aldehyde carbon should get the least possible number. This is number 1, 2, 3, 4. Why you should number from this side only? Why not from this side? So the functional group carbon should get the least possible number. So in this way you are getting 2 positions. So it is called as 2-chlorobutane. 1 all you can write. If it is on first position, if you don't write it also, it's understood that it is on the first position. Okay, generally aldehydes are generally terminal only. They cannot be in between. Okay, so this is 2-chlorobutanol. Okay, or butane 1-ol also you can write it as. Now I will take another example. Okay, just try this. So select a chain of carbon atoms, the continuous chain. So 1, 2, 3, 4, or 1, 2, 3, 4, 5 carbon atoms. 4, 5, or 1, 2, 3, 4, 5 carbon atom. Pentane, aldehyde, pentanol. Right? Transition. Now number the chain from this side only. 1, 2, 3, 4, 5. So these are not in the chain. So these are substituent. You have chloro and methyl. When there are 2 substituent, you should write it in alphabetical order. Alphabetical order, chloro comes first. Chloro, methyl pentanol. So number it. So there are 2 positions. Second position that is chloro. Third position that is methyl. So 2-chloro, 3-methyl pentane. You can even write it as 1-ol also, or if you don't write it also, it's understood, pentanol. So 2-chloro, 3-methyl pentanol. Are we getting this? So this is the IUPAC name. Now, if there is a cyclohexane type, I mean, if you have an alicyclic compound like this and an aldehyde. Okay, so when aldehyde group is attached to a ring, alicyclic or aromatic ring in the IUPAC system of naming, so then what is done is generally a suffix carbaldehyde is used. For example, this is cyclohexane. Cyclohexane, carbaldehyde. Even for benzene, if you have benzene, I mean benzaldehyde, if the benzene carbaldehyde is IUPAC name. Okay, so generally, but IUPAC accepts the common name of this. The common name of this is benzaldehyde. Okay, so these names have been adapted by IUPAC also. For example, the simplest benzaldehyde. So we use benzaldehyde both in common as well as in IUPAC name. Okay, so some of the names have been adopted by this IUPAC also. Okay, even though this is the IUPAC name, generally benzaldehyde is more commonly used. Okay, now whenever the same name is used for the parent compound, both in common and IUPAC system, then the substituted compounds, I mean if there is any substitution, They are indicated by Greek letters alpha, beta, gamma in common system and by Arabic numerals 1, 2, 3 in IUPAC system. Okay, so you can use that, or else even you can use carbaldehyde also, no problem in that. But you can even use benzaldehyde also. Okay, benzene carbaldehyde or benzaldehyde. Okay, no issues with that. Now, so in common system, the position is indicated by using for example, we'll take an example only. If you have this compound, okay, in common system, so this is benzene carbaldehyde, okay, cyclohexane, okay, cyclohexane carbaldehyde. This is cyclohexane carbaldehyde, cyclohexane carbaldehyde. There is a substituent there. The substituent is methyl. Okay, now, so carbonyl carbon, this carbon is alpha, this is beta, and this is gamma. So in common system of naming, the name goes like this: gamma methyl carbaldehyde. If you go for IUPAC system, okay, if you go for IUPAC system 1, 2, 3, so it will be 3-methyl cyclohexane carbaldehyde. Okay, so this is the difference. So if you are going for the common system, then the position of the substituent is indicated by using the Greek letters, whereas in IUPAC it is indicated by the numbers. Okay, next one is the naming of the ketones. Okay, how the ketones are named. So ketones are also carbonyl compounds only. These also contains C double bond O group. The only difference is both the positions, carbonyl carbon will be linked to alkyl or aryl groups. If one of the groups that are linked is hydrogen is linked, then it will be an aldehyde. So in common system of naming, what is done is the name of the alkyl groups that are present on either side of the carbonyl group is named, and then at the end ketone is written. Okay, in common system, the names of both the aliphatic or the aromatic, they are written. Or if there are two alkyl, or there may be two aryl group, or there may be one alkyl or one aryl group, so they are named in alphabetical order. Okay, then the terminology, at the end suffix ketone is used. For example, this is the methyl group, this is the methyl group, so dimethyl ketone. It is popularly known as acetone. If you take this C2H5, C double bond O CH3, okay, you have an ethyl group and you have a methyl group. So alphabetical order, E comes first. So ethyl methyl ketone. So ethyl methyl ketone. Okay, looks like this. You have a methyl group and you have a phenyl group. Methyl phenyl ketone. Popularly known as acetophenone. So there is a phenyl, so phen, there is a ketone, so one, so two carbon atom, acid. So acetophenone is the common name used. Okay, now If there are substituent present, then they are on either side of the chain, then they are indicated by using Greek letters alpha, beta. So since there are two carbon chains here, I mean two chains here, so one is named as alpha, the other will be alpha dash, like this. I will just go for an example. If we have a compound like this, okay, this is acetone, CH3C, derivative of acetone, so you can write it as acetone. Okay, so you can name this chain with alpha, so this can be written as alpha dash, right? So there is a chloride alpha as well as alpha dash, so alpha comma alpha dash dichloroacetone is used. This is the name used. Are we getting this? Right? So in aliphatic ketones, the position of the substituent on either side of the parent chain are indicated by Greek letters alpha, alpha dash, beta, beta dash, etc. Okay, beginning with the carbon next to the carbonyl group designated as alpha, alpha dash, like this. Okay, for example, I will take another example so that it will be easy for you. Now we'll take this. If this is compound, we have CH2, like this, right? Now, so one chain will be, we will go for alpha, the other will be alpha dash, this will be beta dash. Okay, so there is a bromo group and two carbon atom, bromoethyl. There is chloro and one carbon, chloromethyl. This is how it is named. Okay, so this chain as well as this chain, so I can write it as beta dash bromoethyl, alpha chloromethyl ketone. Okay, bromoethyl chloromethyl ketone. Okay, now IUP system, hope you know the IUP system, where the name depends upon the number of carbon atoms that are present in the parent chain. The only thing is, in aldehydes we used to use the suffix al. Here the suffix on is used. For example, if you have this, three carbon atom, prop, single bond, propane, there is a ketone, propanone. Simple way of naming, right? If you have this compound, how many carbon atom? 1, 2, 3, 4, 5. So I think there is another methyl group here. Just so select the longest chain. This should include the functional group carbon. Functional group carbon should be included in the chain. You can use this 1, 2, 3, 4, 5, or this 1, 2, 3, 4, 5. 5. Pentanone. Okay, there is a methyl group. So methyl pentanone. Numbering should start from this end so that the functional group carbon gets the least possible number. Right? Functional group carbon is getting 2. Pentane 2 on. So 4 methyl. 4 methyl pentane 2 on. This is the way naming. So if there is an aromatic, Okay, this is acetophenone, or in common system of naming, methylphenyl ketone. In IUPAC, there are two carbon atoms. Eth, carbon-carbon single bond. Ethane, there is a ketone, ethanol. This is the chain that we should select, right? So numbering from this side only, 1, 2. We have two carbons only. So first position there is a ketone. To the first position there is a phenyl group. So phenyl ethanone or 1-phenyl ethanone, ethane 1-O. Okay, this is how we name it in the IUP system of naming. So this was general introduction about the ketones and the IUPAC naming as well as the common system of naming. Okay, in the next session we'll be dealing with the reactions which are very important for a syllabus, nucleophilic substitution reactions as well as some of the other named reactions. Okay, thank you.